Hi, this video is going to illustrate consumer maximization or consumer optimization when you have a corner solution or a non-interior solution. Let me show you the image of this graphically and then go through an example to illustrate a scenario that you could have a corner solution as the optimal bundle. So here's the picture. You've got this blue budget constraint. You've got your two goods, burritos and pizzas, and suppose your indifference curves, in this case, look to be very flat. And indifference curve, pink, I1, I2, and I3. Of course, I3 is preferred to 2, which is preferred to 1. You want to obtain the highest indifference curve that spends all of your money. So note, in this case, there is no tangency like we saw previously when we had an interior solution. Where the pink and blue are just touching is at this far left corner, where you spend all your money on burritos and purchase no slices of pizza. So this would be a potential corner solution, or the optimal bundle. The best bundle lies in the corner, not a tangency. So let's go an example of this. So suppose your utility is a function of two goods, bananas and oranges, B and O. And this function is written as 3 times bananas plus 2 times your number of oranges. Anytime you have a plus sign here in your utility function is a strong indicator that these goods are perfect substitutes for each other. So let your price of bananas be 20 cents, your price of oranges be 15 cents, and you have $3 in income. Find your optimal bundle of bananas and oranges and show this on a graph. So let's do this. Let's graph the budget constraint. So let's graph this budget constraint here in green, and let's find the slope. And the slope is going to be 15 divided by 20 will be the slope, or 0.75. That's the slope of the budget constraint. Now let's sketch the indifference curves. And sketching the indifference curves, here they appear in red. And how do we know the indifference curves have these shapes? Well, consider the case where you have 2 bananas and no oranges. 2 bananas would get you 6 utils, and no oranges will get you a total utility of 6. So if you give up both bananas, now you have 0 bananas. How many oranges do you need to get you a utility of 6? You need 3 of them. 3 of them. So our indifference curve has a slope of 2/3. Our budget constraint has a slope of 3/4. They will never be tangent. So the optimal bundle is not here in the corner because, yes, it spends all our money. However, we can get a further indifference curve, which is this one from the origin. And so the optimal lies up in this corner. You spend all your money on bananas, 15 bananas, no oranges. This is the optimal bundle. And note the solution appears not as a tangency or interior, but on the corner of this graph. That's why we say it's a corner solution. This is not your typical case, but because we have an additive utility function indicating the goods are perfect substitutes, it's common for perfect substitutes to have the optimal bundle being in the corner, either here or the optimal bundle being in the corner